We're really excited to be here today talking about this fantastic project which we just started a few months ago. The main aim of the project is to develop farmer preferred varieties that are more nutritious and also are more resilient to climate change by using some of the latest genetic technologies that we pioneered here at the John Innes Centre. There is a fantastic opportunity that's been afforded by recent funding that we received from the Foreign Commonwealth and Development Office to work with the CGIAR Institute being led by ICARDA and with work by CIMMYT, and also with our partners across Kenya, Egypt and Pakistan. Working with Kenya was an obvious choice, and of course KALRO is an organization that we've been working on for several years. This project now allows us to tighten that relationship, and it's very exciting that we already have seeds on the ground from the first day of the project.
So it's really fantastic to be involved in this new UK-CGIAR Centre, where we've been funded to develop a project where we're looking at how we can actually improve rust resistance and also iron content within wheat varieties that are kind of locally adapted to different areas in the global south. Within this project, the goal of my research is to look at how we can improve rust resistance. And so within our lab, we identified 3 genes where we can disrupt their function, and that can then give us increased resistance against these wheat rust pathogens. And we decided to work with KALRO because, of course, in this particular region, in Kenya, they have a huge problem with wheat rust infection. And so it's really important that we improve resilience against the wheat rust, particularly in Kenya. And so that's why KALRO is so important within this project.
Diseases of wheat are critical. As we know, Kenya and this region sits in an area that is vulnerable to rust diseases. But you know, the small-scale farmers that have 10 acres and below of wheat often are more vulnerable to this because they hardly have access to resources including fungicides. And so many of them, for those who have not accessed some of our varieties, often lose anything 90–100% of their wheat.
Farmer who planted the susceptible wheat line will not harvest anything. So that's how important these rust diseases in terms of yield loss. A farmer can lose everything.
100% loss means that farmers are kind of taken out of production. And you know, farmers, for them to grow wheat, more often than not, they access loans from banks, friends, and sometimes when they are put out of production, then the net effect is that Kenya remains a net importer of wheat, which is not desirable.
This project started only a couple of months ago now, and we started the project by initially planting some of the lines out in the field here in Njoro, and we're now just starting to screen those plants. So far within the John Innes Centre, we've been able to test those wheat varieties in the greenhouse, but what's really fantastic is that we're now able to take those lines into the field in places like here at KALRO in Njoro, and we're able to plant those in the field and see how they actually behave in our target countries where we want to deploy these. At the moment, the lines that we're working on here in Njoro, those lines have been generated through mutagenesis. And so the next step will be utilising some of the great advances in genome editing in order to edit the genes that we've identified, selecting wheat varieties for that genome editing that are locally adapted to growing here in Kenya.
My main role is to lead in screening lines that we shall be developed from our partners to resistance to these diseases. This collaboration grows stronger and be enhanced because of the results you have already demonstrated, so that you're able to benefit humanity, you're able to benefit especially the people who work directly for, the farmers.